Hi, hello everyone. Last time we left off, basically with our rotations, and this time we're actually going to uh, try to do some gameplay, and for that we're going to have to deal with input and then creating a player. So by input I mean just keyboard input, the way of moving our player. So for that we can already start with basically input class or our input manager class that's just basically going to handle input. And in JavaScript or the TypeScript JavaScript, it's rather easy to do. So we're just going to create input manager, this, and then export class, put manager. So here we can just have some method, private key down, which is going to take our key string and it's for value it's going to be boolean. So then we have our public initialize. And here we can just say window, add event listener key down, and add event listener key up. And here, this is wrong suggestion, so we can just say on key down. So we're going to receive event here. So, and key is true. Sorry, this is key down. All right. This should be fine. So basically we set up this and similar we set up this, but on key up we set it to false. So we can just inspect our key with is key down and then we can have is key up as well. So whenever we press any key on the keyboard, it's going to register it, put it in a dictionary, set it to true, and otherwise it's going to set it to false. And for the keys, usually you can just Google it, JavaScript keys events. So let's see, what does it have? We are using here key. And it's just string representation of the pressed key, and you can find somewhere key codes. I'm not sure, but we're going to use these ones. Arrow down, arrow up, arrow left, etc. So that's going to be easy. Alright, we have our input manager. We just need to create it in our engine. So I'm going to do it like this. Right over here, we're just going to say private input manager. And it's going to be new input manager. Alright, it already added it, and then wherever we can just set it here. Input manager.initialize. We initialize it, and then we actually need to create our class that's going to represent player. So let's do just that. Actually, I'm going to everything related to game. I'm just going to put it in a game folder and then create a player. So we're going to have export class player. So for our player, we're going to need our, well, basically sprite sheet. So it's going to have something called movement direction, and it's going to be of type vector2. So we're going to need this. We're going to need private drawRect. So we're going to need private sourceRect and texture. And then we can have our constructor, and we're actually just going to take private input manager of input manager, and then we're going to get our player sprite from our content. Maybe content can be injected as well. You can decide upon it. I'm just going to leave it static. Probably not the best practice to leave it static, but it is what it is. So we're going to have draw rect, but this is not going to be this, since actually it's fine. This draw rect, but since it's a bit dangerous to modify this draw rect and this source rect directly because it's passed by reference. So in our rect, I'm just going to create a small method, public copy, which is going to return rectangle, and it's just going to return basically the same rectangle, but it's just so that we don't pass it by reference. So here I'm just going to say copy, and here I'm going to say copy as well. And then we're going to have update method, and we're going to have draw method. And the draw method, we're actually going to pass our sprite renderer, and then we're just going to use that sprite renderer. So let's just finish draw method. This is really simple. It's nothing that we haven't used already. And in our update method, so here it gets a bit more tricky. So we're going to need set movement direction. I already have suggestions, so let's just see if they're good. Actually, let's just remove this. So the point is we're going to reset our movement direction. We're going to edit to movement direction, right? If we press up, we set it to, this should actually be -1 and this should be 0. Sorry, 1. Arrow left is fine, arrow right is fine. So movement direction will just say, are we going up, are we going down, where are we going? And then we can also now say this direct dot x plus equals this movement direction, and the same for y. And we can also add some const speed, and then multiply this by speed. No, actually, we can do it even better yet. There is a better way to do it, and we can just say this vector to scale. So this will multiply our vector times some scalar, and we can just pass this movement direction, this speed. So it essentially does this, right? This movement direction times equals speed, right? But since we cannot support this with the arrays or objects in TypeScript, I'm just using this vector to scale method. So this is fine, probably now. So let's just create our player, and for that, I'm going to refactor our engine a bit. So we're going to have two callbacks that we can attach to. One is going to be called on update, and I'm just going to have empty implementation for now. And the other one is going to be on draw. All right. And instead of doing it like this, I'm going to create on update here. And then we don't need any of this anymore. So let's just get rid of all of this. I'm going to cut this too because I'm going to use it, but here I'm going to call this on draw. So then in our main, we had this, but here I actually want to do something different. So I'm going to say not render. This is going to be called engine because it is engine, and engine is going to have on update, and engine is going to have on draw. So just some refactoring. So I'm going to paste this sprite render, but it's engine sprite render. But it's not. Let's just make this public. This can be public as well. All right. So our engine, and here we can create our player. Const player is new player. All right. So here we're just going to say player update, and here we can say player.draw, and we paste that sprite render. if everything is alright, we have our player, he's moving, so that's good. Alright, just one important thing that I wanted to discuss, because we're not multiplying by delta time, and what's happening is this player might run faster or slower depending on your machine, depending on your load. So essentially it could go too fast, too slow. Anyway, uh, if 1 second passes, he might be a different position than what he needs to be. Let's say that he needs to pass 100 pixels in 1 second, but that might not happen because we're not multiplying by delta time. And so how do we do that? And actually, what's the point of delta time? Well, the point is when 1 second passes, if you want to move 1 to 100 pixels, let's actually do it like this. I haven't started this. Give me a second. So let's imagine it like this. Wrong. My bad. My bad. I actually needed. Where did I put it? In media screen brush. That's what I'm always using. So let's say our player is here, right? And we want to move it here in 1 second. But the issue now is because our computer might run too fast or too slow, he might end up somewhere over here, or he might end up somewhere over here, depending on the load. But this will probably not happen, right? So what do we need to do here? Well, we need to have some sort of variable where our player has this variable speed. So now we have second here, but let's just say 1 millisecond here. So we know it. And so we have our some variable speed. So how do we move? How can we normalize this? Well, you can multiply this speed times delta time. Sorry for this. So speed times some delta time. And delta time is actually going to take into account this part, right? And this part. So here, if we're slower, it might appear more janky, more like there might be, it might appear like this. So it might not be as smooth, right? It might be here, the frame might be here. It might not appear as smooth as, let's say, 60 or something that's fast. Let's say here we're rendering maybe 60 frames per second, right? We get more images here. Here we're rendering 30 frames per second. So the animation will be more smooth, but the delta time will guarantee us that we're always at the same position. So let's do just that. And how do we do that? Well, it's actually really easy. So here we're just going to take delta time. That's going to be a number. And here on update, we're just going to pass some delta time. And how do we get it? Let's see. So this is going just to be, we can have some constant, call it now, and there is performance and now. So this will give us our timestamp. So we can just, this dot time means this last time. So we need to create some variable called last time. And we can set it to performance now, that's all right. And then here, this last time is equal to now. Maybe we can just set last time to 0 as well. Okay, we have that. And on update, we're just going to paste delta time. And our player is still not using it. So we need to start using it actually. So here we get delta time, we paste it delta time. Our player is not using it. So let's just do that number. And then here we can multiply just this speed times delta time. And he's off somewhere in the world. Interestingly enough, because I haven't saved everything, so let's just do that file. Which file isn't saved? Engine, main, so now it works. All right, let's see, that's way too fast. We can reduce speed, let's say 0.25. All right, that's quite all right. So we fixed that. there is just one small issue here that remains, and that has to do with our input. So if we press right, it's alright. If we press up, it's alright. But if we press, for example, right and up at the same time, you might notice that diagonally it goes way faster than it should be, like in right, and then diagonally it's actually going a bit faster in diagonal direction, and that's has to do with vectors. So it's really simple here. So what happens is this. So we move 1 unit on press here, and on press here we move 1 unit as well up. But if we press both, we actually move here 1 unit and here 1 unit, and this vector that's basically going to 1 1 is actually longer than either of those. So these have a length of 1, and this is length of 1 plus 1 squared. So it's something 1 plus. Anyway, not important. The important part is that this vector is quite a bit longer than this or this. So we just need to take that into account. And how can we do that? Well, we can just normalize our vector. So here, before we scale it, we can just say vec2 normalize this movement direction, this movement direction. So we're normalizing movement direction, and this will write it into movement direction, and this is the vector that we take in, and that's it actually. That's it, and now it should work. So yeah, diagonally it isn't going faster than right or left. So yeah, that will work. Anyway, hopefully you enjoyed this video. In the next video, I'm going to add some enemies, and then we're going to deal with the collision as well. So if you have any additional questions, you can also join Discord group. Also, if you have suggestions as well. So if you like this video, please like, subscribe, and until next time.